Hello, I'm David Tower, and welcome to the Theories of Everything program. Viewers, in previous programs we've examined a number of aspects of the universe and space-time. We've looked in fact at the nature of space-time and reality on several shows, and we've also examined the nature of dark matter and the nature of dark energy that seems to permeate space as well as the normal galaxies and stars. So we've been around a whole lot of areas relating to space-time, the universe, etc. And for a long time, the whole concept of multiple universes or parallel universes has been with us as well. Right, in fact, from early 1957 when Hugh Everett proposed the multiple worlds interpretation, a number of parallel universes basically. And going back even further in quantum theory to the nature of superpositions or nature of multiple states of entities, including our own universe. And there's been a vast amount of work ever since. So in this update series, we'll focus basically on the whole concept of multiple universes, or as it's now termed, the multiverse. In very recent times, in fact, particularly since the last MAP survey was done, the survey of the cosmic background radiation, the variations in temperature and density of our universe. Since that time there's been a much greater consensus among physicists and amongst cosmologists on how our universe really is, its real shape and its context. This consensus has risen just recently, in fact, in the last 6 months to new levels. And it's for this reason that we're going to examine the whole concept of the multiverse, as it's now termed, and as it's been written recently in publications such as New Scientist, examined recently in Scientific American, etc., major articles dealing with it. So it's timely that we do this. So what is the new evidence? The consensus only arises because there is new evidence. The conjectures may have been around for a long time, and some of the theory, but the evidence is pouring in. The major evidence is in the shape of the fluctuations in temperature in the cosmic background picked up by the latest, by their shape, by their geometry, that in fact space is flat. They would be a different size, a different geometry if space was curved over, or if it was of a different shape, a donut shape, for example, spherical shape, any number of shapes, but it appears to be flat, and it appears therefore that space is either very large or in fact infinite. That's the first major piece of evidence, and that will be confirmed over the next few years by further satellites, by further analysis. The second major piece of evidence relates to the structure of the galaxies in our particular part of the multiverse, in our universe. Basically, the galactic distribution of matter, the matter distribution in our universe, has been initially clusters, smaller galaxies, larger clusters of galaxies, superclusters, but at a certain point it all levels out, and matter, the distribution of matter, becomes fairly standard, becomes, if you like, routine. And therefore, if in fact our universe is just a tiny speck in a larger multiverse, that type of distribution would probably continue into the rest of space. And therefore there must be, unless there's very special circumstances in our universe, there must be matter, galaxies, stars, planets and life right through the multiverse at large. So these are the two major pieces of evidence: the understanding that space is flat, and the understanding that matter permeates in a fairly routine, random way the whole multiverse, or beyond our universe as it continues. There is no barrier. There is no sign that says stop, space ends here anymore. It just continues. So the ramifications of that, and you can call that, as Max Tegmark did in the recent Scientific American article, you can call that a level 1 multiverse, where there are likely to be virtually an infinite number of our Hubble volumes, or our universes if you like. Different compositions, but the same laws of nature, the same sorts of constants, the speed of light, the charge of the electron, the mass of the electron and subatomic particles, those remain constant, but different initial conditions, different fluctuations at the beginning, causing slightly different distributions of matter and so forth. And if space is infinite, if the multiverse is infinite in size, you will inevitably repeat exactly the situation we have here today. You will repeat, in other words, you and I and everything on this planet and everything in this universe. And you will repeat that, if space is infinite, an infinite number of times. So we exist in an infinite number of other universes. We also will be doing all sorts of other different things, and in many universes, of course, we won't exist. You're beginning perhaps to see, viewers, the glimmerings of the ramifications of this new expansion of our knowledge, this new theory, this new expanded theory of the multiverse. And we'll reassess the ramifications at the end of the program. Now, viewers, we come to the level 2 type multiverse. The level 2 type multiverse is postulated by cosmologists as allowing this multiverse, this level 1 multiverse that we've been discussing, multiple universes, to exist as a subset of a much larger multiverse. Again, infinity within infinity. Now, the reason that this is postulated is because of inflationary theory. Inflation was the process that's gained dominance in recent years for the creation of our universe in the first place, from the Big Bang. A vast explosion of energy which expanded and created our universe, and that possibly came about because of a reduction in the number of dimensions, a symmetry breaking, if you like, as string theory postulates, from an original 10 spatial dimensions splitting into 3, which expanded with the energy surge into our universe, splitting off 7 that curled up into very tiny forms which are too small to see. That's one theory of inflation. This energy surge occurred anyway and explains most of the phenomenon that we see around us today in this universe. Now, cosmologists such as André Linde have postulated that this process of inflation can occur again, this symmetry breaking can occur in different universes, in different multiverses, in the multiverse, if you like, and create a whole new multiverse, a whole new series of universes in a chaotic process. It's called the chaotic inflationary model, over and over again, perhaps an infinite number of times. These multiverses are distributed again through an infinite space. That's one theory of how an enlarged multiverse, an infinity within an infinity, could perhaps come about. There are several other alternative proposals. One is, and one of the most recent ones, and one of the most interesting ones, is that in fact our universe exists as a three-dimensional membrane floating within a larger space of 5 or 6 dimensions. For example, and 2 of these three-dimensional membranes clashed, creating a vast amount of energy which creates another universe, in fact another multiverse. So large is the energy released in that process. That's the so-called brain theory, where the 2 membranes, the 2 three-dimensional membranes clash and create more. That's another way that additional multiverses could be created. The third way is postulates an evolutionary process by Lee Smolin. Probably the most interesting concept, that in fact universes can be created out of black holes. As we know, black holes can swallow billions and billions of suns, vast amounts of mass, matter and energy, and it just disappears somewhere in this infinitely curved gravitational field of a black hole. But the theory by Smolin says that this can occur over and over again, each time creating new universes. Some of these universes might be quite micro and fade away, but others will grow larger. They will create more potential universes or opportunities for universes that are again larger. By the way, that creates more opportunities for life, because a black hole is created from a supernova explosion. A supernova explosion creates carbon, which is another heavier element, which is the basis of life. So that process continues with mutations of universes over and over, and some of which get larger and larger and end up allowing us to exist. The so-called, and we view this universe from our perspective, this is the so-called anthropic principle, a life perspective. We see everything in terms of us in the universe, whereas we look at it as a very special process. It may be, but it may not be. But whichever of those three models is taken, it has the potential to create new multiverses, new multiple universes again. These are distributed more sparsely in space, but they still exist, and so it creates another huge potential dimension of universes and a huge potential for us to exist over and over again. Now we come to the third type of multiverse, the one traditionally associated with parallel universes, the one on which many of the TV scenarios are based, the weird world of quantum physics. Now that multiverse is based on quantum theory, broadly. It's based on the fact that, first postulated by the early pioneers of quantum theory, like Niels Bohr, who postulated that in the Copenhagen interpretation, that superpositions of subatomic particles, and even us exist simultaneously. But when these multiple copies, if you like, or multiple variations are measured or observed, they decohere into a classical state. In other words, we see the things around us not as multiple copies, but as just one ordinary thing. That was the Copenhagen interpretation, but that left many doubts in many physicists' minds, because it happens instantaneously, apparently, and that defies laws relating to the speed of light, for example. But the Everett model in 1957, which says that entities exist not just in superpositions, but actually that decohere, but actually exist as multiple copies. That interpretation of quantum theory took a while to sink in. It's non-intuitive, and physicists, cosmologists, scientists in general, are very loath to take this on board. It seemed as too enormous, because every time a decision is made, a decision as to whether to go and have a coffee, a decision to get married, a decision to whether to study a particular subject, whatever, then this, under Everett's multi-world interpretation, or multiple world interpretation, many world, there was a split. Now some interpreted that as a split in the universe, so you'd have one universe where one thing happened, another where another happened. But the sensible interpretation is that it's the observer, the measuring device, the system itself that does the splitting, if you like, not the whole lot into two universes. So when we make a decision mentally, we split into two and follow two different paths. The entity follows a different history through different events in different universes. So if you go back in time, for example, if such a thing was feasible in the future, which is likely to be, if you stayed in this universe, went back in time, everything would change in the present. So the past there'd be constant chaos. Time travellers would constantly create variations in the current scenarios. But that wouldn't happen, because if they did go back, they'd create a new history. They would travel through different events in different universes. And this creates a new concept of time. Not so much an evolving thing in one sense, but the events already exist in an infinite number of universes. And when a split is made by the observer, by a human or whatever, a different chain, a different causal chain of events is created or connected. Different events are connected in different universes, and you travel through those to create a different life. So you wouldn't know whether you've made a decision to do something, but you don't know that the alternative decision has been implemented in another universe, through another chain of events, through another history. So we've got multiple histories here, not multiple worlds or multiple universes in the classical sense. Level of evidence for the quantum theory, for the many worlds, the latest many worlds interpretation that says all possible scenarios do actually exist, comes from the in different universes, comes from now from fairly solid evidence in the area of quantum information. Quantum computing, in fact. Quantum computing says that we can compute something very, very quickly, much faster than a classical computer, because it can do the calculation in parallel. If you have a number of components, if you have 10 components, in other words 10 different possible states called qubits, it can perform a calculation in all those states simultaneously. And in fact it can perform it in that case in there'll be 2 to the 10 different states, 2 to the power 10 if there are 10 different components, 10 different subatomic particles in different states, and spin up, spin down, etc. Whatever way you want to measure those bits and interpret those bits, it means that as you increase the number of components, as you increase the number of quantum bits, this level multiplies and multiplies and multiplies by a factor of 2, so that you end up, when you end up with say 100 qubits in a quantum computer, and it's now feasible, the first quantum computers are about to be created as we speak, containing 2 or 3 qubits, but when you reach that large number, it means you can compute in a few minutes what would normally take the entire length, entire age of the universe to compute using classical, even very fast classical computers, using normal bits, operating serially and not in parallel, if it all occurred just in this one universe. So in fact, what has been postulated is that these calculations in parallel are done in little pieces of other universes and brought back together for the final answer. Strange again, but the facts say that as you increase that level of qubit complexity, you just can't do it in one universe. It's impossible. Therefore it must happen in multiple universes at a quantum level. And now, viewers, we come to the fourth of the possible multiverse scenarios. This, in a sense, is the most difficult, non-intuitive to comprehend. For others, such as the major advocate of this theory, Max Tegmark again, it's a very sensible approach. And for most mathematical physicists it is also, because in the realm of mathematics there is a division. For ordinary mortals such as us, the mathematics is just an outcome or an extension of our brain that we use to interpret reality. If you like, it's the Aristotle type interpretation of mathematics. It's a facility that has evolved to enable us to generate patterns regarding our existence. For the mathematical physicists, for the mathematicians, they have a more Platonic or Plato-based approach. They believe that mathematics exists externally of space and in perfect form. The equations, the objects, the structures of mathematics exist beyond, if you like, our normal cognitive powers. But we have discovered those forms in many ways. We've used very powerful forms of mathematics to interpret our reality. But our reality is the flawed thing, not the mathematical structures. So you have two versions. Regardless, there is some consensus that if the universe was composed along different mathematically structural lines, it would evoke different properties. Not only would the constants of nature be different or evolving, not only would the initial boundary conditions be different, but also the laws of physics would be completely different. The laws of relativity, of quantum physics, statistical mechanics, thermodynamics, electromagnetism and so forth would all be different, because you'd have an entirely different sort of structural universe. The evidence for external mathematical structures is the fact that no matter what civilization on Earth, and possibly beyond Earth, generated these structures, they would all turn out to be fairly similar. In other words, mathematical equations, mathematical identities, etc., mathematical objects seem to be immutable regardless of who or how they're invented. They do seem to be invariant. So what Tegmark proposes is that there's an ensemble of these mathematical structures that can all be realised in a reality such as a multiverse. We exist in one of those structures that creates the laws of physics as we know it. But again, it's an ensemble approach, just like the level 2 multiverse. We live in a type of universe, multiverse, in which we can exist. Therefore, we can infer that there must possibly be other alternatives outside that, and he infers the same thing, that there must be alternative mathematical structures that are realisable outside the laws of physics, laws of nature that we invoke, that we exist in. So there you have it, viewers. You have a complete ensemble, if you like, of levels of the multiverse, which are now considered to be, except perhaps for the last one, level 4, the mathematical one, considered to be significantly close to perhaps a theory of everything, or a major truth. Now, what does this mean? Well, it means, viewers, not a lot, just that the entire philosophical, theological and possibly scientific structures on which our civilization is based, and which we have developed to date, are in for a substantial revision, may even have to be completely overturned, certainly at the philosophical level and the theological level. When you have an infinite number of us, it challenges notions of free will for a start. It's not deterministic, everything's possible. It challenges notions of death. If we're alive if we die in one universe, are we still alive in others? It challenges notions of God, of a God. Is this the sort of scenario that a God might have planned? And on and on and on. And we'll discuss these in future programs, the philosophical ramifications, the social ramifications. We exist again almost in a virtual reality. We exist in our own day-to-day worlds in which survival is essential. We try to progress our lives and improve our quality of life. Beyond that, all this other stuff is happening. It doesn't seem to have a lot of connection, but in fact it does. All major breakthroughs in science have had direct realisable connections with our social lives. Inventions of new materials, products, internet, for example, communication, the whole lot. So inevitably, these new scenarios, these new multiverse scenarios, will play a large part in our future lives. I'm David Tao, and you've been watching the Theories of Everything program again. I'll look forward again to seeing you next week.